Okay, so today we are going to solve this merge sorted array problem, and first we will see the brute force way and then we will optimize that one. So the question is, we have to merge two sorted array. So we have given two arrays, nums1 and nums2, and m and n are two integers representing the number of elements in the nums1 and nums2. And the final sorted array should not be returned by the function, but instead be sorted inside the array nums1. It means like we don't have to create any third array here for output. Inside the nums1 only we have to append the nums2 elements, and only the condition is that the output should be also in sorted in non-decreasing order. And to accommodate this nums2 elements, they have already given like nums1 has a length of m and n. So this array length will be like m plus n. M elements will be initialized and the remaining n elements will be 0 0 0. Like these are the elements which are already initialized and their n elements will be 0 0 0. These 0 0 0 elements we have to replace with these elements. Once we replace, then we have to make it in a sorted. So what we can do, simply we can copy all these, place it here and do arrays dot sort, but the complexity wise it's going to be nlogn because array dot sort is complexity is nlogn. So that's a brute force way, or you can say it's the easiest way, but complexity wise it's not a good efficient solution. So let's first try to solve that way and then we will try to see how we can write optimized solution. So we have to copy this to this, so we have to run a loop on this, take all the elements of this. So let's say int I'll take a last element from the reverse loop I'll run, and then say I should be greater than 0, and then we'll say I minus minus, because last element will take and place it here. So placing it here we need pointer here, right? So how to get this pointer? We'll say PMerge pointer merge, and size will be m plus n minus 1, right? Like it's 5, 3 plus 3 6 5. The hyper pointer will be here initially. So I'll take a value of this, and in the nums1 we have to place it, right? Nums1 PMerge at the 5th position, we will take a value of I is I means nums2I, right? We will take a value of nums2 I, place it here, and then we need to PMerge minus minus. Then our pointer will come here, and then we will take a value 5, place it here, decrease it PMerge here, and then take a value of 2 and place it here. That's what is happening here in this loop. Once this is done, we are saying arrays dot sort and then nums1. This is the easiest solution, but the complexity wise this is not a good solution. Okay, what is happening here? This is going to be a for loop. I 5 is greater than 0, that's true, and minus 1 we need to do. This is the reason. Okay, cool. It should be accepted. Submit. It should work. It's just a 2-liner code, right? But now complexity wise this is not a good. Now let's try to solve. So what we can do now, if we see closely one, and this is another input array, what we can do, we have to, so the condition is that it should be in the sorted non-decreasing order. It means the biggest element will be in the end, right? So what we can do, we'll take this element, the biggest element will be this only, right, at the end, and here in the biggest element will be at the end, right? That we know because this is in the increasing order. So this is the biggest element here and this is the biggest element here. We can compare these two biggest elements here first, and whichever one is bigger we will keep it here and move the pointer. If let's say 3 is greater than 6, no, 6 is greater, so we'll place it 6 here, and then pointer move this pointer here, and then we'll compare 3 with 5, and that way we will go. So we need one pointer p1 here, we need one pointer here, and this is a PMerge pointer we needed, right, where we want to keep those elements. So let's, and with this we will be able to solve. So we will need a p1 pointer m-1, and we need another pointer p2 n-1, and is nothing but 3 minus 1, 2 pointer will be here, this pointer will be here, and finally one more pointer we need merge, where we want to keep the values, and that will be the m plus n minus 1. Okay, now we want to run a loop. So all these elements we want to keep it here. Once this is done, then we'll come out of the loop. So we can say while p2 is greater than equal to 0. Okay, and then we can say if nums1 p1 is greater than nums2 p2, if this is greater, then we want what? We want to replace nums1 PMerge at the PMerge position we wanted, right? At the last position, what we want? This is greater, so we'll take this value and keep it here, right? This is what we want to replace, and we want to decrease PMerge minus, and also what we want to p1 minus. Because now we want to replace, move p1 here, right? Else, if this is not the case, it should be in the reverse way. So what we need to do, if this is not the one, then nums1, this is going to be the same, and then what value we will replace with? Nums2 p2, right? And what we will decrease? PMerge anyway will get decreased, minus will get decreased. This will get move here, right, from 6 to 5. Okay, and then this is fine. And then one more condition we need to keep it here, in case if this array is empty in any scenario. Let's p2 already we are checking here, so let's check p1 also here. P1 should be greater than 0. Let me try to run. Let's see. Okay, this is accepted. Let me submit. It should get accepted. Perfect. And this is improved version, right?